be using all the formulas in this list. And as you can see, we have already used most of them. We have already used the median, the mode for interval distribution, the mean, that was the first one we used for raw data, mean for group data, variance and standard deviation for raw data, variance and standard deviation for group data. That's supposed to be row, Spearman's, and now we're on Pearson's. And then later down the week, we're going to use those two there. Okay. And there's another set of formulas on probabilities that is assignment D. So that's the formula we're going to use. So here's number 11. Part C says calculate the product moment coefficient for this set of values. Now, correlation is the measurement of the relationship between two variables. Measurement, as we talked about measurement already, you will get a number after you measure. Take for example, you're looking at somebody and I say, well, that person tall, okay. And I look at another person, might say, but that person short. Another one might say, but that person medium. So this is a subjective way of analyzing. Now, when you have subjectivity, you have different opinions and you have varied answers. So that is why we need mathematics to be objective. So what will happen now? The mathematician will come, devise a measuring device, like a measuring tape, measure the person's height. So you have height, which is the variable, and measure the person's height to get the data, and then you'll get a number. So no one can dispute that number. They will have to blame the measuring tape. But everybody will have the same number to work with, and then that's how you have progression happening. Okay, so therefore now it's the same thing that happening there. You might suspect there is a relationship between hours of study and score. That's just a hypothetical example. There are many other examples where variables interact with each other. Okay, so now one might say, yes, the amount of hours, affecting your score. Plenty, no, a little bit, and then you have debate, that's subjectivity. Now, what about measuring that correlation to get a number? Okay, now, here now you're talking about an abstract relationship between two variables. So the tool now, you have the thermometer, you have the measuring tape, you have the scale. The tool for doing that are the formulas. We use Spearman's to measure, right? Just like how you have different brand of thermometers, different types of measuring tape, you have different ways of measuring the correlation. Okay, and here we're going to do it using Pearson's now to get a number. Now that number now cannot exceed 1 and it cannot go below -1. Please bear that in mind. I think we talked about that already in number 11 part A. Okay, so you can revise number 11 part A to make sure that this is so, and any formula you use for measuring correlation, it must be between -1 and 1 inclusive. It can be -1, it can be 1, but nothing away from that. Okay, so here's the assignment, and part C now, part D now saying to calculate the coefficient of determination. We're going to do that after. Okay, now a template has been given to help with that process. Okay, in the test, you will have to develop your own table. But here in the assignment, a table is already provided, and some first numbers are already done, just to give you a head start. Okay, so here you have the example now. The numbers are similar, but they are different. You have 5 and 45. So I kept the 5 and 45 because I didn't want to go and recalculate all of that again. So I kept the 5 and 45. Okay, but all the orders are different. You have 22 and 78. Here you have 25 and 76, and so forth. Okay, so the formula now, that is the longest formula in the course. Okay, R for relationship is equal to, so you have a division because it's a coefficient you are going to calculate, a 0 point something. So to get a 0 point something, a division, most likely will happen. If you look at all the three formulas we analyzed, there is a division to get a decimal. All right, a division again. Kendall has a division and Spearman has a division. Okay, right, so R is equal to N times the sum sign of x times y, because we're measuring the correlation between two variables. One is x and one is y. X is the independent, y is the dependent. That means x affecting y, okay? And by how much, that's what we're trying to measure. Minus the sum of x, okay? I'm writing the formula instead of copying and paste it. And even though the formula will be given to you, you can write it also, you know, to get accustomed with it, you know, to learn it, to get a feel for it. Okay, that's what it's all about. Okay, you will not be required to memorize it, but you know, write it out, and then, you know, because I don't think how many of you all have seen that formula, use that formula before. I doubt any one of you all. So you're learning something novel, something brand new. So I think it's a good idea to copy down the formula, you know, to get a feel for it. All right, because there's a lot of sigma in it. Or every term has a sigma in it, and then you have an n there, and then you have a sum. Okay, the sum of x squared. Now remember what we said about sigma. Eh? We said that you have to complete all what is to the right of sigma first before you sum. Okay, complete all what is to the right of sigma first before you sum. Okay, so this is for x and this is for y. Okay, and y. So this formula has, I separated this formula into 6 parts. Okay, 1, 2, 3, 4. Well, 1, 2, 3, 4, 5, 6.